Hi, Tor Lacey here with a lecture about the geology and biology of the Middle Paleozoic. During the Ordovician, low-growing vegetation clung to the shorelines of seas and lakes, while inland the landscape was barren. However, during the Silurian and Devonian periods, life left the confines of water and spread across the continents. For most of the Middle Paleozoic, animal life resided in aquatic environments. Large, complex reefs, supported by tabulate corals and stromatoporoids, coral strome reefs, evolved in the shallow, warm waters covering large portions of most of the continents. The first jawed fish evolved. Acanthodians were one of the first, and resembled modern fish, with paired fins and scales instead of bony plates. The armored placoderms were the top predators, with some growing as large as 23 feet in length. Ray-fin fish, the direct ancestors of modern fish like trout, bass, and tuna, evolved at the end of the Silurian and diversified through the Devonian. Fish fed on the easily accessible trilobites, causing their numbers to decline. In Silurian time, plants were limited to very moist environments like shorelines, lagoons, and tidal flats. The evolution of roots, seeds, broad leaves, and stems allowed plants to spread across the landscape, and by the late Devonian, lycopods were a common early plant, and like others of this time were seedless and confined to wet, swampy environments. However, in the Devonian, the evolution of roots, seeds, vascular stems, and broad leaves allowed plants to spread across the land. Seeds provided a protective casing around plant embryos, meaning they were no longer dependent on moisture for reproduction. Vascular tissue transported water and nutrients upward through plants, as well as providing structural strength needed to grow tall. Broad leaves captured more sunlight, making for more efficient photosynthesis. By the end of the Devonian, the landscape was covered by vegetation, so it looked dramatically different than at the start of the Silurian, when it was mostly barren rock and sediment. The invasion of plants also impacted terrestrial geology. Roots gripped sediment, allowing for thicker soils to form and influencing overland runoff, forcing water to flow in discrete channels. In fact, it wasn't until this time that the first meandering rivers were established, as evidenced by the stratigraphic record. The proliferation of plants also increased the rate of weathering of rock, a process that consumes atmospheric CO2. Decreasing CO2 means less heat is trapped in the atmosphere, and global temperatures decrease. By the end of the Devonian, Earth experienced an ice age. The drop in sea levels accompanying the ice age led to one of the greatest mass extinctions, wiping out most ammonoids, brachiopods, and placoderms, and the coral strome reef communities never recovered. So the biology affected the geology, which in turn affected the climate, which in turn affected the biology. As vascular plants spread across the landscape, animals evolved to feed on their decay. These included millipedes and flightless insects, to which later arthropods adapted and became carnivorous, such as centipedes, scorpions, and spiders. During the Devonian, lobe-finned fish evolved into the first tetrapods, amphibians. As vascular plants spread across the landscape, animals evolved to feed on their decay. These included millipedes and flightless insects, to which later arthropods adapted and became carnivorous, such as centipedes, scorpions, and spiders. Amphibians could not explore land until a vascular plant canopy was established, which provided the shade needed to keep the skin of amphibians from drying out. So during the Devonian, lobe-finned fish evolved into the first tetrapod, amphibians. Tiktaalik was likely one of the first and is an example of a missing link between aquatic and terrestrial animals. For most of the Middle Paleozoic, sea levels were relatively high. Laurentia was positioned near the equator, where it was flooded by warm, shallow seas, creating widespread basins in which coral reef communities flourished and carbonate and clastic sediments eroded from recently uplifted mountains could accumulate. Mountain building along the eastern margin of Laurentia was renewed. Recall that at the end of the Ordovician, the growth of the Appalachian Mountains in eastern North America started with the Taconic Orogeny, which constructed mountains in the region of modern-day New England. This second stage of the Appalachian Orogeny is called the Acadian Orogeny and was more substantial, being more prolonged and affecting a larger region of Laurentia, from Canada to Alabama. The mountain building of the Acadian Orogeny was driven by two successive collisions of continental masses with Laurentia. First Baltica in the north, then Avalonia more to the south. These continental collisions not only built up the Appalachian Mountains, but brought together modern-day Scandinavia and Greenland, and islands that would become the British Isles. These continental collisions happened over a period of about 50 million years, resulting in the assembling of the ancient continent Euramerica. Additional continental masses collided later, culminating in the assembling of Pangaea. In summary, during the middle of the Paleozoic, during the Silurian and Devonian periods, life continued to evolve in shallow, warm seas. Coral reefs thrived and fish developed jaws, scales, and some adapted to become ferocious predators. Plants spread across the land and developed adaptations that allowed them to diversify, grow, and colonize the landscape, such as vascular stems and seeds. An ice age caused another devastating extinction event, and mountain building happened along the eastern margin of Laurentia, as continents and microcontinents collided. Okay, that's all for now. Thank you for your attention.